Now, class, this is a very important piece of mathematical theory. You absolutely have to know it, and if you don't know it, you might as well just walk out of the room because you're never going to go further in math class ever. Okay? The microphone's not that sensitive, Gervier. All right, so number system. The only reason this actually has any real application is sometimes when you are dealing with data, you have to be aware that the numbers you are using might not exist. For example, if you were doing a graph of people, you wouldn't have any fractions, right? Because you can't have half a person. Everybody understand? No, Yulia, you can't. Even if I got in a horrible accident and lost my left arm and my left leg, it would be all right because I'd be all right then. Get it? I lost my left arm and my left leg, but I'd be all right. I know. I'll be appearing here till the end of January. Anyways, I'm still a whole person, right? I also don't call my brother my half-brother because I have more than an arm and a leg as a brother. All right, everybody good? Okay, so that's why this is important. Important. Say nice air quotes. Say it real loud. Yeah, you. Because you're the one that's trying to mess up my thing by saying nice wink. So you might as well say nice air quotes really loud so the microphone picks it up. No, you're okay? All right. Gervier Sidhu, everyone. My good friend Gervier Sidhu. He'll be appearing here till January too. Well, off and on. Sometimes. Yeah. Once, twice a week. Guaranteed. No way. All right. Natural numbers. These are, and you probably don't even need to write this down, counting numbers. It's up to you. What's the first number we start with when we count? Nobody says 0. If we were in grade 3 and I said, let's all count together, children, and I would say, go, we'd all go, 1, 2. We wouldn't say 0. So the counting numbers, the natural numbers are 1, 2, 3, up to what? Infinity. Will we ever get there? No, because infinity doesn't exist. Everybody cool? All right. The whole numbers. When I say whole numbers, all of you think, oh, numbers without fractions. Not true. Whole numbers are the counting numbers, which we call the naturals. And this is where we add 0. So it's 0, 1, 2, 3, up to infinity. Everybody good? Ease, peas, lemon, squeezy. Now, all of these numbers have an abbreviation that they use in math class. All right? The natural numbers are N. The whole numbers, oh shoot, I should have done that in red. The natural numbers are N. The whole numbers are W. I should have done that in blue. Whole numbers are W. And actually, I think natural numbers might be Q or some stupid letter like that. I don't remember. Because it doesn't matter. Huh? Anyway. The integers are the next one, and they are the whole numbers and the negatives. So it's negative infinity, -1, -0, 1, 2, up to positive infinity. Everybody cool? You all know this already. That has an abbreviation too. That abbreviation I know is I. Then you got to draw a line. Because all of these have no fractions, which automatically means they have no decimals. Easy peasy. I want it out of the way. That's why I'm doing it first, so I never have to talk about it again. And if you forget anything all year, this is the one page you can forget. Okay? Okay. Now, rational numbers are everything else that is a fraction or a decimal. Okay? Rational numbers are all fractions, and most decimals that we will deal with. And rational number looks like this. Written that way. X and Y are integers, and Y can't be 0. Anytime you see anything that's written like that, it's a rational number. The only rule is this. Why do I say most decimals? Because the decimals have to terminate or repeat. So, for example, terminate 7.3876. Rational number. Why? Because it's a decimal that stops. Everybody cool? Repeat 7.3866666. Rational number. Why? Because the 6 keeps going. Everybody cool? That's it. And then the last bunch are the irrational numbers. And these guys fit nowhere else. So, like the square root of 2 doesn't exist. If you punch it into your calculator, it's 1.414, blah, 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 blah. It fills up the whole calculator screen. So, all non-perfect radicals. And I'm going to review what radicals are in the second unit, as you can see. Those are irrational. And then a few famous numbers, like pi is irrational. 3.141596, blah, 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 blah. There's a computer working on pi. It's been working on pi since like the 60s. It's up to like 20 billion decimal places. It hasn't repeated yet. It's not going to. There's a few other famous irrational numbers. We don't deal with them in grade 11 at all, so I'm not going to talk about them. Okay? But there's a bunch of numbers like pi. They're just a decimal that goes on forever. Everybody cool? Everybody has this committed to memory because it's so darned important that you absolutely need to know it? Okay. Turn the page over now. Let's get to something that actually is important. This is going to be your first bit of work today when I stop talking. You're going to fill in this page in a few minutes. Turn to page 7. And again, you didn't get my cool font, did you? You got a bunch of dots, right? Damn. It's a nice font, eh, Parvesh? I know, right? I don't know why. It's called bomb font. Yeah, I probably shouldn't say that out loud. Somebody will think, some FBI or Homeland Security guy will hear me talking about bombs on a math thing, and it'll be on YouTube, and then they'll come and get me. Bomb, 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 bomb.
Wrong jurisdiction.
No. The FBI, Americans watch my YouTube things. I know it's weird, right? What kind of loser who isn't in the class actually watches somebody else's math videos? But there's a lady in Houston 8 years ago who was watching my videos. I don't know if she still is. She sent me an email. I told you this. When I stopped doing them for summer, the first year I ever did them, she sent me an email. And she's like, why did you stop? It's like, it's summertime. And she's like, oh, when will they start again? September. Oh, thanks. Why? She's the only person that's actually a fan. Or so I think. Huh? No, you're not. Okay. That's how you keep passing, because you never come to class. So. All right. You guys could fill this in already. 7 to the third is what? What does it actually mean? 7 times 7 times 7. Now, some of you at some point in this class are going to tell me that that answer is 21. You're automatically going to do it. Ashton's already laughing because first thing he thought was 21. But what is it really? 343, right? You all know this already. Like I said, this is a review of grade 10. Which is the base? 7. What does that mean? That is the thing. No, I'm not going to say thing. I'm going to use a math word. That is the expression with an N, you idiot. Expression that we multiply. Now, the thing that kids always forget is when it's one single thing, it's no problem. It's like it's 7. 7 times 7 times 7. Duh. But what if it was this? 3ab cubed. Now what's the base? 3ab, the whole thing. Okay? What if I gave you this? 3ab cubed. Now what's the base? Just b. Excellent, good. And the exponent, in this case, is what? 3. And the exponent is the number of multiplications. Now, for you people in your math lives, that exponent is always going to be a number. Next year, that exponent is going to be a variable, and you will learn how to deal with that. So instead of x to the 7th, you'll be dealing with 7 to the x, and you'll be trying to figure out what x is. But we don't do that in grade 11. Julia's, what? Yeah, it's badass. You'll figure it out. Everybody good? Now, you have to remember this scenario. That 3 applies to everything here, but only to the b here. You cannot forget that. All right? But we're, of course, going to review all that anyway. Power is the whole thing. And since blue and red make purple, the power is 7 to the third. A base and an exponent. You have to have them both. And we read it as 7 to the third. The special names, there's only 2. That one and that one, which is squared and cubed. Now, in the next minute or so, fill in that sheet. Those of you who are in my grade 10 class have seen that chart before. Yeah, no problem. I'll slide back up there. Fill in that table right now as best you can. You can talk to your neighbor. You can do it out of your head. You can get a calculator. I don't care. Do what you have to do to fill in that table. What color am I feeling today? Somebody say a color. Green? Dark or light green? Light green? So there it is, all filled in. I am highlighting a couple of things that kids forget when they do these. Everybody should have been able to do it. Everybody should also be able to explain why I have highlighted some of these things. Why is this 3 highlighted? What is the mistake that kids often make? I bet a few of you right away accidentally put -3 there. I hope you didn't. Why not? Why is this 3, Aiden? It's not in brackets. The base is only the 3. So what's different in this one? The 5, the negative is part of it. So I have to keep the 5. So in this one, the negative is in both. In this one, it's at the end. Everybody cool? All right. What's weird down here? Why would I have highlighted that one? Because you need the brackets. Why do you need the brackets, Gervir? Because the negative keeps repeating. So you need all those brackets. Because the negative is part of the base. Everybody cool? Okay. Why did I highlight this -2 here? And this negative? Because it's not part of the base. I had a positive base, but a negative answer. So the only way to get that would be to have a negative out in front. Everybody cool? And what about this one? Why is this row a pain? Because there's 2 negatives. The negative had to repeat, And since it was 6 times, I would get a positive answer, wouldn't I? Because negative times negative times negative times negative will eventually end up with a positive answer. But I had the extra negative out front, which has to be at the end. Is everybody cool with the easy exponents? Everybody remembers how to do them? Your brains have woken back up to math? Enough? We're cool? All right, turn the page over. We're going to review the 7 rules. They will take 2 minutes, and then I'm going to shut up and let you work. Okay? But did this font come out for you guys? Oh, it did. This font is called Bats and Dragons. Don't be scared. It's just a font. There are no real bats and dragons. Holy, you want to hear something funny? Last night, 2 nights ago, I'm sleeping, and I hear, "Wah!" And I'm like, what the hell? It was my kid. He woke up in the middle of the night, and he picked up his phone to check the time, because he doesn't have a clock in his room. So his phone lit up, and sitting on his phone was a spider. A big spider. One of those spiders that if you're dead silent, you can hear its feet. That's how big it was. And he was, "Ah!" And I go, what the hell? Sidjan, you okay? And he's a boy, right? So he doesn't want to say, a spider just crawled across my phone and scared me. So he's like, "Oh, I'm fine." And then the next morning, I was like, "Dude, why'd you scream last night?" And he's like, "There's a big spider on my phone when I picked it up." Because he put it like right here, right? And the spider was still there. Then we hunted for it in his room and we found it. Then we set it free in the backyard because we're nice. No. Spiders are good. Huh? They eat bugs. Would you rather mosquitoes and flies flew around without any spiders to eat them? What? You guys aren't scared of spiders, are you? Are you really? Like, I'm not putting you down, but you're really scared of spiders? Some people are. My exchange student last year, this German kid, he's like, "Matt, yeah, there's a spider in the bathroom. So deal with it." I can't. I'm too scared. I had to go downstairs to his bathroom and save him. He's a 17-year-old boy. But my kid is scared of wasps. If there's a wasp in the room, he just leaves. He's so scared of them. He's been stung. He knows it doesn't hurt that much, but he's like, "Nope, nope, nope," and runs away. Then my dog figured out, now my dog hunts wasps. Like when we go to picnics and stuff and the wasps come around, my dog runs around. Sometimes he gets stung and he's like, and he's trying to lick where he got stung because he's so stupid. Dogs are so dumb. I don't know why anybody thinks dogs are smart. They're so stupid. Wouldn't see a cat getting stung. All right, let's move on. Multiplying powers at the same base. What's that look like? X squared times x cubed. What's the answer? X to the 5th. Why? Because it's the same base. So this is really x times x times x times x times x, which is x to the 5th. What's the shortcut? xa times xb is x to the a plus b. Super easy, right? I don't know why anybody has trouble with it. And yet, it's the worst unit in all of grade 10. Even though the entire unit fits on one page, it's still the worst unit in all of grade 10. What's dividing powers at the same base? What's the answer? X to the 1. Why? Because it's x, x, x over x, x. Cancel, cancel, and I'm left with 1. The shortcut, Aiden, is we subtract. X to the a divided by x to the b equals x to the a minus b. Raising an exponent to an exponent. X, I want to change color. X cubed squared. What's that? X to the 6th. Why? No, that's what we do. That's not why. Because it's x cubed squared, so I write it twice. And then that's x, x, x. Naughty. X, x, x which is x to the 6th. Now tell me what the shortcut is. X to the a. B is x to the a times b. Everybody should be good to there. All of you should know that. Inside, outside, backwards, forwards, upside down, underwater. If I taught it to you in Greek, you should be able to do it in Greek. Does everybody remember those 3 laws? Great. Now, the problem, and don't write this down, is people forget that all those laws apply all the time. So what? Don't write it down. Just think about it. 3a squared b cubed squared times 2ab. What would that answer be? You can write it down if you need to, but you would need some of your own paper to find a space to work. Or you can just think about it. I don't care. All of you should be able to do that almost like that by now. So that would be 3 squared, then what? A to the 4, 6, times, what's over here? 2ab. What's 3 squared? 9. What's 9 times 2? 18. What's a to the 4th times a? A to the 5th. What's b to the 6th times b? b7, and it's done. All you should be able to do that easily in your sleep, right? Okay, what if I add this to the mix? Now what? You already know what that is, right? What was it? 18a 5b7, right? Over. So what's the answer? Okay. Do I go further? Now what do I do, Gervir? Right. So it's 9a to the what? 3b to the what? Over what? 2. That's the first 3 exponent laws all in one question. Is everybody good with them? You could all do that. Obviously, it gets more difficult, but it's the same rules, right? Everybody's good? Okay. Now we start getting into the ones that are a little funky. A fraction base. What's that? Why? Why is this the right answer? Anthony?
Because distributive property with brackets.
That's what you do. You distribute. But why? Because it's a base again. X times x times x over y times y times y. X times x times x, x cubed. Y times y, y cubed. And as Anthony says, x to the a over x to the b all to the c is x a times c and x b times c. C, not 3, you idiot. Everybody good? Okay. Exponent of 0. What's that? 1. What's this? One. What's this? -1. Why is this one -1? Because there's no brackets. Because the negative isn't part of the base. Everybody cool? Do you remember why? Oh, you do you? You want the magic pen? You'll show everybody? Why is this true? You gonna do it? All right, yeah! Ladies and gentlemen, my special guest, Pavraj. Please, applause. Yes! Oh, here, no, by all means. It'll be warm, though, because I've been sitting in it. I know that feels gross. I didn't fart, though. Oh, absolutely. Oh, this one is warm. Did you fart?
No.
I'm just kidding. Go.
Which one do we show for?
I want to know why x to the 0 is 1 and why negative x to the 0 is negative.
Okay. See, like right here, it has a bracket and you have 0. So like that gets like multiplied out and you only get 1. And like right here. Yeah, that's it.
Mr. Pavraj?
Yeah.
Why?
That's why.
I see. Okay, switch. Thank you. That's cool that you tried. Oh, it's warm again. Okay. Seriously, though, for all, to save the arguments, this is why it works. What is 3 squared? 9. What is 3 to the 1? 3, right? What math did I do to get from 9 to 3? Division, right? Going downwards, I divided, right? So when I dropped an exponent, I had to divide by the base, right? So what is the next logical exponent? 2, 1, 0. So I must have to divide by the base again, right? What is 3 divided by 3? 1. That's why it works. Here's the other reason why it works. 3 squared over 3 squared is what? 3 to the 2 minus 2, right? Which is 3 to the 0. But isn't 3 squared also 9 over 9? Which is 1. Everybody cool? That's why it works. That's why this negative still is a positive 1. Everybody good? Okay. And lastly, this is where everybody gets screwed up. And this should be number 7. I don't know how this happened. But let's get number 7 out of the way because it's easy. XY cubed is what? X cubed, y cubed. That's supposed to be a 3, but my pen stopped writing. Same as the number 5, right? The exponent just goes everywhere, right? But now we get to negative exponents. And this is what messes you guys up. All of you who've been in my class will remember that x to the negative 3 is what? Ashton? Go ahead. Somebody go. You guys are like those chipmunks on cartoons. Oh, no, after you. No, after you. No, I insist, please, after you. No, after you. I couldn't possibly.
All right, so what you want to do is do 1 over x, and that x has the power of 3.
Right, because this can't exist, can it? How could you take x and multiply it by itself negatively? This is easy. Everyone says, I got it. It's no problem. Until I put it in a question. And then everyone's like, ah. Or if I write this, everyone's like, what? What if I gave you 1 over x to the negative 3? What's that? That's x to the 3. Makes sense. You flip it around. Okay, what's this? X over y to the negative 3. You flip it, so what does it become? Y over x to what power? Positive 3. Easy. And yet, people have so much trouble with it. I don't know why. So, again, you don't need to write this down. Just see if you can do it. See if you understand. 3x cubed y squared over 4x to the 5th y to the 6th, all to the negative 2. why this is difficult is a lot of you do this in a different order, right? Some of you will take care of this first. Is that okay? Sure. Some of you will take care of this first. Is that okay? Of course it is. I can't teach you every possible path you could do here, can I? So you got to know how the stuff works so you can choose your path. Everybody cool? So would anybody like to tell me what they would do first with this question? What they would do. Not the answer, just what you do. What would you do first, Anthony?
Well, first I would deal with the negative exponent and flip it around.
So you would take care of this.
Yes.
So what would happen to this base? What would you write it as? X5, y to the 6th over x3, y squared. To what power?
The 2.
To the positive 2 now. Now, even if you wouldn't have done that first, do you understand why Anthony did and what happened? Okay, what would you do next? If Anthony was on your team and Anthony started and did this and he tagged out and you came in, what would you do next? What would you do? You'd bring the exponent in? So you would get 4 squared x to the what? 10 y to the what? Over 3 squared x to the what? Y to the what? Okay, now you tag out. Next person on the team, what would you do next? If you were inherited this question, you would deal with the x's? Hina, right? Okay, so you would have 4 squared over 3 squared, and then 10 and 6, what would that give you? 4. Right, so x to the 4. 4 is positive, we're happy. Right? What would you do with 12 and 4? Y to the 8. 8's positive, we're happy. Right? Okay. What would be your last step if you were on Anthony, Pavraj, and Hina's team? 16 x to the 4th, y to the 8th over 9. Everybody cool? Could we have done it in a different order? Would we still get the same answer? Who makes that decision? You do. I can't tell you the order you will follow because I am not in your head. I don't understand the way you see this question. Everybody cool? All right. Nice. Let me make a small change. Everything's the same except this. These two are now negative. Who would like to tell me their first step? Again, there's no wrong way to start. You would flip which? Hina's going. Which? Where? What would you move, Hina? You want to deal with which negative? I see 3. You want to deal with the big negative or these little negatives? You want to deal with the 2 or the 5 and the 6? Your call. You want to deal with the 5 and the 6? Okay, so Hina's on your team. She says, I don't like these 5s and 6s. They're both negative. They're already on the bottom, so where do they need to go? Up. So I'm going to end up at 3x cubed, but I'm going to bring up this 5 now. And y squared, I'm going to bring up that y to the 6th, and all that's still going to be over 4. And it's still going to be to negative 2. Right? Because we didn't deal with that negative. So now you're on Hina's team. What would you do next? You already had a turn. Somebody else. You've inherited this question. What would you do next? You can't volunteer somebody else. Because that's like saying, we need to go on this deadly mission. Send Kyle. There's no chance you're going to come back alive. Kyle's your man. Seriously, what would you do next? Now you would want to deal with this negative, so you'd flip everything again. Okay, so now you'd have 4 over 3x3, x5, y2, y6, and all that would be to what power? 2. Okay, you've inherited that. What do you do now? You're going to bring the 2 in? Okay. Are we at an appropriate level where I can just write 16 instead of 4 squared?
Yep.
16 over 9, x what? 9. 6, x, 10, y, 4, y. Now what? You've inherited that. What do you do? 16 over 9, x to the what? Y to the 16. Is that okay? We get to the end? And we used 4 or 5 people's methods, and we still got to the end. Even if you didn't do what they would have done, or what I would have done, you were still able to get to the end. Is everybody cool? Sweet. All right. Something weird happened on the next 2 pages. Page 9 and 10 are the assignment. Don't do them yet. Page 11 to 14 is the practice. Page 11 to 14 has answers on page 15 and 16, or 15. Okay? Do the practice first. Check your answers. Make sure you're doing it right. Then do page 9 and 10, because that is an assignment. We are going to mark it for marks. Does everyone understand? Do 11 to 14 first, because it's got the answers. And don't forget, you still have page 6 to fill in. And you have until 11:08. That's 25 minutes. Right? Tomorrow, we will be marking page 9 and 10 for marks. If you are the type of kid that you know you're not going to do any homework tonight, maybe you want to do 9 and 10 right away. But it's an assignment for marks, which means, should it be my work or your work? Your work. Which means, are you asking me about page 9 and 10? No, because that's your work. After you do page 11, or after you do pages 11 through 13, you would have all the tools you need to do 9 and 10, because you can check your answers on 11 to 13. Everybody understand? I don't know how the pages got reversed. They just did. Cool? Go. Cool.